So in this section, we're going to take a look at something called the intermediate value theorem, and I'm thinking that this is going to be kind of, or at least I'm hoping it's going to be a common sense type of theorem for us. The wording might get a little confusing, but we're going to go ahead and take the time to kind of draw a picture about what this is saying, and hopefully that picture is a good visual for us to understand what this intermediate value theorem actually means. Now, just for the name itself, some of us might not be familiar with the word intermediate, and that's just a synonym for between. Very similar to how some school districts have an intermediate school that's usually found between elementary and middle school. So you can kind of use that word intermediate for something that's between two things. So the intermediate value theorem tells us that if we have a continuous function, meaning no holes, no jumps, no asymptotes, okay, that three-part holy trinity of continuity exists, and, okay, so we have another stipulation, and a y value is between f of a and f of b. Okay, this function notation is just representing the outputs from the x value interval. So if those two things are true, then there is at least, okay, at the very least, one x value, maybe we'll call that c, between a and b, that beginning and ending point on the interval, such that f of c equals y. Meaning, if we were to take that c value and plug it into the function, we would get that y value that's between the previous outputs. So at first glance, reading that information might go over our head, but let's go ahead and try to draw a picture to make this make a little bit more sense to us. So we have an interval from a to b, and notice how it's a closed interval, so we should have some points at the x value of a and b. So I'm going to go ahead and draw a point there, and maybe one here. Now, if we plug in an x value into a function, we're going to get out a y value, aka an f of a value. So this output we can label as f of a, and this output we can label as f of b. So we have a closed interval, two dots that have some specific outputs. Now notice how f of x has to be continuous. So you need to connect these dots with no hole, no jump, no asymptote in between them. So I don't really care how you connect them. It could be a straight line, it could be curved, like a polynomial would be, but you somehow just have to connect the dots. So what this intermediate value theorem is telling us, that if we know there's a y value between these outputs, for instance, maybe somewhere right there, then there is at least one x value, okay, some input down here that would give us this y value as an answer. So notice how if I know that this is a y value, the graph actually has, the one that I drew on here actually has three solutions. So we would have some x value here, some x value here, and another one here. So in this case, you actually have three c values, but you have at least one of them, depending on the type of graph you draw. So moral of the story is, if we can confirm that a graph is continuous on a closed interval, and we know that the y value is between the outputs from the interval, then we must have an x value somewhere between a and b. So we're going to practice that in this section, just taking a look at graphs and analyzing, does the intermediate value theorem apply? Okay, do these criteria check out? And if it does, maybe we can actually figure out that special c value, okay, that special x input that is within the interval. So let's take a look at these two graphs. We're first just going to practice, okay, does the theorem apply? Are we able to use it? So this is a piecewise function, and we have the graph given to us, which is always nice. We're going to go ahead and take a look at the bottom one first. Okay, does the IVT, intermediate value theorem, guarantee a value for c such that if we were to plug that in, we would get 2? And they're specifically asking us about the interval from -5 to 2. So on your graph, if you only look at the interval from -5 to 2, we got to ask ourselves the two questions. Is the graph continuous on that interval? Well, if you take a look at the graph, clearly it's not, because we have this jump going on and open circles as well. So since it is not continuous, we cannot use the intermediate value theorem since continuity was a condition. So does the intermediate value theorem guarantee a value? We'll say no, because the graph of f of x is not continuous on the interval. Okay? So the intermediate value theorem does not guarantee a value, but that doesn't mean a value doesn't exist. Okay, so there still might be a special point available to find, but the IVT is an existence or a guaranteed theorem. Okay, are we guaranteed to have one? No, but there actually could be one there, and maybe we can find it. So even though it's not continuous, if we were to go to the y value of 2, notice how we would cross our graph at some point, and that special x location is somewhere between -4 and -5, which is clearly within the interval that they gave us. So is there an actual value? Yes. Okay, so we'll say between x equals -5 and -4. So even though there is one, we initially were not able to guarantee that there was one. Let's try the next one. So different piecewise, or actually same piecewise function, same graph, but the only difference is notice how we're changing the interval. So this time we're only looking from -1 to 5. So with an arrow, that would continue on to the right. So does the IVT guarantee a value for C such that the output would be 2? So we got to ask ourselves those conditions. Is the graph continuous within that interval? Notice how there's no hole, no jump, no asymptote in there, so it is continuous. But the other stipulation is that the y value is between the outputs. So for this output at -2, we're somewhere right here, and this output at 5, I'm sorry, -1, we're somewhere right here, and this output at 5, we're somewhere right here. The y value of 2 is somewhere all the way up here. So notice how 2 is not between these outputs. So again, the IVT cannot guarantee a value. No, because the y value of 2 is not between, let's see, f of -1, we'll say was about -0.5, and the output for 5 was maybe -3.5. And clearly 2 is not between those. So the IVT does not guarantee a value, but there may be one there. Okay, like the previous one, there could be an actual point. If we take a look at where we drew that line of 2, though, clearly we are not touching the actual graph that we have on that interval. So in this case, there is no value that would work.